Alrighty, guys, we're going to take a look at the 30-60 right triangle. The ratio of the sides is the 1 to radical 3 to 2. The 1 being the side opposite the smallest angle, the 30-degree angle. The radical 3 opposite the 60. And then the largest side of your triangle, the hypotenuse, that is 2. And we're going to talk about and discuss how to use that ratio to find side lengths. Basically, when do I multiply, when do I divide to get different side lengths? The easy one to typically talk about is the short leg. If I've got the short leg length of 5, the question is, how do you find the other two side lengths? Well, I always work through the short leg. No matter what's given, I look at the short leg and one other side. And since I'm looking for the hypotenuse right now, the key number between that is the 2, because multiplying and dividing by 1 doesn't do anything. So I would either multiply or divide by 2. Well, this is pretty simple. If I'm going from the short leg to the hypotenuse, it is getting larger. When it gets larger, you multiply by the key number here being 2. So I multiply by 2, and you'd get the hypotenuse of 10. Likewise, to find the long leg over here, I've got to decide, well, what do I do? Well, the key number is the radical 3, because once again, 1 doesn't do anything. It's getting bigger going from the short leg to the long leg. So as it gets bigger, we multiply. And since the key number is radical 3, I take that side length of 5 and I multiply by radical 3. All right, let's go a little further with that. What if this time instead we take a look at the hypotenuse? What if my hypotenuse length is, let's say, 5? Well, I said that I'm not going to work with the hypotenuse and the long leg. I'm always going to work through the short leg. The key number between short leg and hypotenuse is 2. It's getting smaller. I divide by 2, giving me 5/2. Really don't want the decimal here, or a mixed number. The improper fraction is the way to go. And then I'm going to go from the short leg of 5/2 to the long leg. Well, the key number is the radical 3. It's getting bigger. When you multiply a fraction times some number, that number just goes in the numerator. So that gives me 5 radical 3 over 2. All right, let's take the last possible scenario here. The last possible scenario would be the idea of, what if I had the long leg? If I have the measure of the long leg, and this time let's say that the long leg is radical 15. Well, I'm always going to work through the short leg. And the key number between the short leg and that is the radical 3. It's getting smaller going from long to short leg. So you would take radical 15 and divide it by the key number of radical 3. And since they're both inside the radicand, we can just simply say radical 5, you divide the numbers. And then going from the short leg to the hypotenuse, well, it's getting bigger. The key number is the 2. So I multiply by 2. So this length is going to be 2 and radical 3. All right, let's go a little further with the long leg. That's typically the place people get more troubles with. So we're going to look at examples when I give the long leg. And the length this time of this long leg is going to be, since I've been using 5 quite a bit today, why don't we call it 5? And when I go from the long leg to the short leg, the key number is radical 3. I would divide by the radical 3. So as I'm dividing by radical 3, I would take the 5, divide radical 3. And when you do that, you're going to rationalize by multiplying top and bottom times this radical 3. And on top, I've got 5 radical 3 over 3. Well, to get to the hypotenuse, the key number is the 2. I'm going from a short leg to hypotenuse. It's getting bigger. Multiply by 2. Putting that 2 in the numerator, well, the 5 times the 2 gives me 10. So I end up with 10 radical 3 over 3 for my hypotenuse. Now, much like the idea of the isosceles right, we talked about in the isosceles right that when you divided by radical 2, that was the same as multiplying by radical 2 over 2. And the same thing is happening here. So if I give you another length of a leg here, let's say it's 7, I would divide by radical 3. But dividing by radical 3 is the same as multiplying by its reciprocal of 1 over radical 3. And the reciprocal of 1 radical 3 always simplifies into radical 3 over 3. So I'm going to suggest that why don't we, instead of dividing radical 3, to save the step of rationalizing the denominator, okay, we're going to multiply by the reciprocal in simplified form. And so when I do that, the reciprocal of dividing radical 3 is to multiply radical 3 over 3, and I put 7 in the numerator when I multiply that. So 7 radical 3 over 3, you multiply by 2 to get the hypotenuse, and you've got 14 radical 3 over 3. A couple last examples here. Once again, going to look at a long leg. If I've got the long leg length of, let's say it's going to be 9 this time. When I take 9 and divide that by radical 3, remember the shortcut is to multiply radical 3 over 3. The 9 and 3 are outside, so they can reduce. So you get 3 radical 3 for your long leg. And if the long leg's 3 radical 3, to get to the hypotenuse, you multiply by 2. Multiplying by 2, you'd multiply the number outside the radicand, which is the 6. And so 6 radical 3 is the length of your hypotenuse. One final one here. Let's take a look at a little fraction action with a fraction. We learned in Nemo that fractions are friends and not food. So fractions are friends, no worries. Oh, no, that was fish. Fish were friends and not food in Nemo. All right, fraction. All right, so here we go. Fraction. Let's say that this is going to be a length of 1/2. And I want to find the length of the other sides. Well, to go to the short leg, I'm going from long to short leg. The key number is this radical 3. Dividing radical 3. Not going to be easy to divide this by radical 3, so I'm going to multiply by radical 3 over 3. And when you multiply 1/2 times radical 3 over 3, you multiply the numerators to get radical 3 and the denominators to get radical 6, or excuse me, to get just 6. So your short leg is radical 3 over 6. And then to go from the short leg to the hypotenuse, the key number is 2. It's getting bigger. I multiply by 2. That puts the 2 in the numerator. So I end up with 2 radical 3 over 6. But remember, if we can reduce, we got to do it. And I'm going to reduce the 2 and the 6, getting radical 3 over 3. And you'd never reduce these because one's inside the radicand, the other one's outside. That can't happen. So your final answer there is radical 3 over 3. Now, once again, only use a shortcut when it's a shortcut. So for instance, when I'm dividing by radical 3, in most cases, it's going to be a shortcut to multiply by the radical 3 over 3. But going back to this example here, dividing by radical 3 was actually rather easy. So dividing radical 15 by radical 3, I just got radical 5. Multiplying by the reciprocal or the simplified reciprocal of radical 3 over 3 would be crazy. So anyway, hope that's helpful, guys. We want to get to the point where you can just look at those 30, 60, 90s and isosceles rights and figure out the lengths of the sides without having to do it on the calculator, and almost as fast as you would your times tables. Probably not quite that fast, but pretty quick. Anyway, have a great day.